All right, hope you guys are doing well. And in this video, we're going to talk about Deepseek R1. It's one of the latest reasoning models that is shaking up the entire industry, and it's on par or it has the same level of performance as OpenAI's O1 model. And so in this video, we're going to show you some of the ways that we're using it, and we're also going to show you how you can use it with function calling to create reasoning agents. And so this is really, really exciting, and this is a developing feature that the team at Deepseek is actually still working on, so it's unstable, but we actually have a way that you can actually start using it right now on your computer and with Flowise to create reasoning agents that produce really outstanding results. And so I've been using R1 for about a week ever since it came out, and the results are really exceptional. I've actually been using it in a client project, and it's actually produced results that, you know, with the given time, I probably could not do myself. And so it's a really, really powerful model and definitely something you should definitely check out. And so before we get started, if you're interested in learning more about agents and how to use Flowise in your applications, we have a couple different products you might be interested in. One is an advanced e-commerce agents workshop where we build an e-commerce recommendation system. And the second is our Flowise Core Essentials course, where you'll learn to build a number of different agents and chatbots for your applications. All right, so let's go ahead and get started. And so the first thing we're going to do is we're going to show you how you can use the latest Deepseek R1 model within Flowise. So the latest version of Flowise supports the Deepseek module. So all you really need is an API key. And you can also access Deepseek from OpenRouter. They actually provide access as well. So when I was creating this video, I actually tried to sign up for Deepseek's API. And at the time, they were having some issues because of, I guess, the demand. And so I actually had to use OpenRouter's version. And so here we have just a very, very simple LLM chain. And in this particular case, I wanted to see exactly what the outputs of, you know, the R1 model was and, you know, how well it could do. And so for this particular example, my system message is you're an astronomer and an advisor who helps the CEO of a company plan missions to space. Please include your line of reasoning when answering the question. Okay, so let's go ahead and just check this out. And we already have it. And what I really wanted to do is I really wanted to test the reasoning features of the model, right? And so that's why I kind of have this this particular scenario where we're planning a mission to Mars. And we have 5 rocket ships with 125 people, and we want to take those people and put them on Mars within 2 years. And we also have 20,000 tons of supplies, including food and materials and equipment. Right? Please give me a plan for establishing a colony on Mars in 2 years. Now, I don't know if this is actually feasible, but I wanted to see exactly how it would respond. And so this is just, you know, the R1 model by itself, and this is the output that it gave me. Right, it says establishing a Mars colony in 2 years with 5 rockets, 125 people, and 20,000 tons of supplies is extraordinarily ambitious. All right, given current technological constraints. We'll see about that. Below is a high-level plan that balances feasibility with your requirements while addressing critical challenges. Right, and then it says note that key modifications to the original parameters, such as rocket payload capacity, may be necessary to align with realism. So it's kind of saying that, you know, this is probably not a realistic plan, but we're going to play along with you anyway and give you some ideas. All right. And so then it goes and starts to talk about, you know, key challenges to think about, including the payload versus the rocket capacity. And so it's probably unlikely that even with SpaceX starships that they would be able to, you know, take our 20,000 tons. And so it says, you know, for context, 20,000 tons would require 200 Starship launches, all right? And so its solution was to basically leverage in situ resource utilization, right? So that's basically, I believe, pre-positioning supplies before you actually get there, okay? And so that's actually pretty cool. And then it says the transit time versus the launch window. I'm not going to read the whole thing, but it really gives us some of the considerations when planning a mission to Mars, right? And then it actually breaks down the project. So, you know, phase 1, pre-deployment of critical infrastructure, right? And then it gives us phase 2, crewed mission deployment. And then it's giving it within the time frame. So the first phase 1 takes place within basically 12 months, all right, pre-deployment. And then let me see, deliver robots, power systems, and equipment to prepare the colony site before humans arrive. So that's probably unrealistic given our current technology, unless we have something else that we don't know about. And then phase 2 is going to take about 24 months. And then the colony set up, again, 24 months. Okay. So even though this is probably not realistic at all, it's giving us some of the considerations, and it's really giving us a lot of really good detail, which is kind of what we're looking for here. And it's breaking everything down. So months 1 through 6, we finalized the robotic and the rocket payload designs, and then by month 25, 26, the colonists land and activate the colony systems. So again, it's not realistic at all, but you can kind of see the way it's thinking. All right. And so this was actually one of the first examples that I, tried when I was really testing it, and I was really impressed with the way that it was working. All right. And so after that, because again, I have had actually used this on a previous project with some script writing, I actually wanted to test the function calling with the R1 model. And like I said, the function calling right now is still experimental, but we can actually test it now using Flowise and Ollama. So Ollama has a number of different R1 models, R1 variants, and the one that we're going to be using to test the function calling is the Deepseek R1 tool calling model by MF Doom. Okay, so all you need to do is go to Ollama and actually search for Deepseek R1 tool calling, and this will come up, and then you'll see all of the requirements for each of the different varieties of models. And so for this particular test, what we wanted to do is we wanted to use the 70 billion parameter model, just because we wanted something that was powerful enough to really do a variety of different tests. Okay, and this particular model requires 43 gigabytes of space, essentially. And so what we want to do is, even though we can actually run this on our own, computer, I actually want to run this on a GPU. And so for this, what we're going to be doing is we're going to be using the cloud service called RunPod. You may have heard of it before. It's an outstanding service that allows you to get access to a variety of different GPUs at a really, really good cost. And so in this particular example, we're going to be using the L40S. It actually has enough power and speed to support what we're doing, and it's actually pretty affordable as well. So the uninterrupted GPU service is about $1 an hour, which is really fantastic for what we need. All right, so if you actually go ahead and get RunPod or sign up for RunPod, what you'll have to do is sign up for an account, and then once you deposit some funds into the account, the UI is super simple and super easy, and they basically help you, deploy your pods by, first you got to choose your GPU, and then what you're going to do is you're just going to go, let's say we just deploy a pod here. We're not going to do it right now. I'm going to show you, take you through the steps. So what you would do is you look for the GPU that you want. In this case, we want the L40S, okay? And all you're really going to do is you're going to edit the template and specify exactly, what you want in terms of disk space and volume space. So in this case, what I did was I specified a container disk space of 50 gigabytes and a volume disk space of 50 gigabytes, just so that when it's installing the model, we have enough space. And then we're going to expose the port that Ollama uses, which is 11434. And then we're going to also add some environmental variables so that we can actually also establish a port. And so all of these instructions are actually on a tutorial page on RunPod, so I'll include that in the links. And so it's very straightforward, and so it gives you access to a very powerful GPU that you can use to test this model. All right, so let's go ahead and look at the first example that we're using. And for this example, we're actually using a sequential agent. And so what I wanted to do is I wanted to create a simple agent flow where we have a researcher and we have a writer, and we ask this team different questions and give them access to research tools. So in this case, our researcher is going to have access to the Brave News Search API as well as the Brave Search API, so they can look up both web search results and also news results, like current news results. And so what's going to happen is that the The researcher is basically going to, using the R1 model, the researcher is going to do all the research that's necessary to answer the question. This is a very simple prompt. And then the writer is going to take that, and the writer is going to basically create the report that we need based on the request. And it's also going to take a summary of its report, and it's going to send it to the 11 Labs API, and that's going to generate an audio of the summarized text, all right, or an audio of the text that it generates. And I did this because I just wanted to test, have a way to test the tool calling functionality or features of the R1 model, all right? And again, this is experimental, so sometimes it works and sometimes it doesn't work in various ways. So for the first example that we're using, let's see here, we asked the question about GPUs, all right? And so NVIDIA, they're about to release or launch their RTX 5090 series. And so our question to the agent was, please compare the costs of buying an NVIDIA RTX 5090 versus renting a cloud GPU in 2025. Assuming I use the cloud GPU 15 hours per week, would it make sense to buy a 5090, or would it make sense just to, to rent the GPU in the cloud? All right. And so this is the answer that it gave us. And so as you can see, it's actually calling our Brave search results, right? And it's getting all of the information from that, from that search result. And then down below, the writer is taking that research and it's basically, rewriting it in a different format, in a different way. And it's also calling the 11 Labs API and taking the text and sending that to the API to produce an audio, right? And so if we go ahead here, and in this case, it didn't actually show the link, but the link is actually in the tool output. So if we go ahead and we actually open that, and we're just going to play the audio for
the NVIDIA RTX 5090 is expected to cost between $2,500 and $3,000. Renting a cloud GPU at $3 per hour for 15 hours per week would cost around $2,340 annually. Over 3 years, renting totals approximately $7,020, making buying more economical if using the GPU extensively over several years. However, for sporadic use or preferring flexibility and access to latest hardware without upfront costs, renting is advantageous.
All right, so the recommendation is that if we're only using it 15 hours per week, then it's better to rent than it is to just purchase the RTX 5090, which makes sense. Now, the math, of course, is going to be dependent upon the rates for the cloud GPU rentals. But what was cool about this was that it actually took the pricing from its Brave search, okay? And that is about the price, I believe, of the 5090. It is quite expensive. And so this is a really, just a fantastic application of being able to combine its reasoning abilities with its web search, right? While we could probably do something, like you could take a model that already supports tool calling and, call the Brave search tool and then send it to the reasoning model. Having one model being able to do the reasoning and also the research and function calling is really, really helpful. All right. So let's go ahead and look at the next example. And this one, we're trying to create a report that analyzes the home energy cost savings of installing solar panels on a roof of a 2,200 square feet home in Austin, Texas. And we're also trying to find out what the initial investment would be and how long it would take to become profitable. All right. So in this case, we actually had a planner. And this is an earlier model, and so the planner was coming up with basically an idea of how to start this, and then it was sending that to the researcher. And in this case, the researcher was using our Brave News Search as well as our Brave Search APIs, and then our writer basically took all of that research, and the key takeaways was that it came up with some figures for the solar panels. And then it concluded that overall installing solar panels on a 2,200 square feet home in Austin can be a worthwhile investment with an estimated annual savings of $1,300 to $2,600 and a payback period of 5 to 10 years. However, it's crucial to consult with a professional solar panel installer to get a more accurate estimate. Okay, so again, I don't know if these numbers are accurate. I would have to actually search that myself, do the research, but as you can see, it's using the research that it finds to create these really detailed answers that are thought out very carefully. And so this is why it is so powerful. And this is just one application that we're using. And in this case, it actually did a couple of different searches, which is pretty cool, actually. All right, so the next one, we actually wanted to continue testing this and see how well it was doing. All right, and so let's go ahead here. And so this one was, we wanted to test its sort of decision-making abilities. All right. So in this case, we have a real estate company looking to invest in Charlotte, North Carolina, and Denver, Colorado. Based on interest rates and local demand, which city would be more profitable for commercial real estate over a 5-year time frame? All right. So it goes here, and in this case, it did not actually call the Brave search results. All right. Maybe it thought it had enough information; it didn't need to do it. It does look like it's, the answer is very detailed, but it didn't actually do the Brave search results. Although it did call the 11 Labs audio API, and in this case, this is the text that is sent. We won't play it, but so it's calling the API, and as I said before, this particular model, this agent flow, both agents are using the Deepseek R1 model, so it's actually using both of them in the same time. All right, so let's go ahead to the next one. That's the audio. So let's go to the next one. And when you're testing this, the model is powerful enough to test a variety of different cases. So you can really get creative. So let's go here. And then this one was interesting. So in this case, we had a consumer 3D printer startup, and we're deciding how to allocate $20 million in funding for 2025. All right. So last year, the company made a profit of $5 million, selling the hobbyist 3D printers at retail for $550. Material costs. Okay. So the question was, should we spend more on increasing capacity so we can produce more 3D printers for 2025? Or should we spend more money on upgrading our existing printers with the latest computer chips, or allocate more money towards advertising to generate more sales? All right. And so this is a type of, problem where it really has to think through all of the different scenarios and exactly what you're trying to accomplish. And this is really, really helpful in terms of helping you think through different issues with, the information that you have. All right. And so it actually did, let me see here. It did a Brave search to actually get some facts and some context. And it says the global 3D printing market is expected to reach between 94 billion and 119 billion by 2030. All right. And then the 2024 valuation. So it gives us some market research. Okay. And then it gives us some consumer preferences, which is pretty interesting. So for 2025, enthusiast builds and professional setups are the most reliable options, catering both to budget-conscious consumers and high-end users. And so it kind of sounds like, 3D printers are becoming much more powerful, much more capable, and those are what customers are actually preferring these days. And then it, takes all of this research, and then it starts to think about the real question, and that is, where should we allocate our capital? Where should we allocate the money that we have? And so it says, okay, so last year we made $5 million. Now we have $20 million to allocate for 2025. The big question is, should we spend more on increasing production capacity, upgrading our existing printers with the latest tech, or beef up our advertising to boost sales, right? So this is the thinking that it's going through. And then it says, first I need to understand where the market is heading. The global 3D printing market is expected to hit between 94 billion and 119 billion by 2030. That's a massive growth for the estimated 24.37 billion in 2024. Our niche is consumer-grade printers, which are seeing steady growth through 2032. Key players like Stratasys and 3D Systems, which are real companies, are already big in this space, which is true. So we need to stay competitive. All right. So this is where it starts to think about the different, options. All right. So option number one, increasing capacity. All right. If we ramp up production, we can meet more demand and possibly lower costs per unit due to economies of scale. But it's in a big investment and it comes with risks if the market doesn't grow as expected, which is, something that happens to almost every company. All right. Option two, upgrading the printers. Adding the latest computer chips could make our printers more appealing, especially to tech-savvy consumers. It might justify higher prices or attract new customers looking for cutting-edge features. All right, the third option is marketing and advertising. More ads could drive sales by increasing brand awareness and attract new customers, but it's hard to predict the return on investment here, right? This is all R1's thinking and reasoning. I think a balanced approach makes sense. Allocating funds to all three areas, but prioritizing advertising might yield the best results, ensuring we both produce enough printers and maintain a strong market presence with upgraded products, right? So, companies are facing this problem all the time. Where do we allocate the money that we have, and how do we grow in a strategic way that makes sense? And that is, adapting to the market conditions, all right? So it says to address how to allocate $20 million in funding for 2025, given last year's profits of $5 million from selling hobbyist 3D printers at $550 each with material costs of $300, I recommend the following allocation strategy. All right, so this is what it's going to recommend. Right, so number one, increase production capacity. Allocate 40%, $8 million to scale up production. This will allow meeting growing demand and potentially reduce per unit cost through economies of scale. All right. So recommendation number two is to upgrade existing printers. Invest 30%, $6 million in integrating the latest computer chips and technology into current models, enhancing product appeal, and possibly allowing for higher pricing. It's a pretty good strategy. And then recommendation number three, advertising and marketing. Dedicate 30%, $6 million to boost advertising efforts to increase brand awareness, attract new customers, and drive sales growth. So let's see here. That is 12. Yep, that's 20. So the reasoning is production capacity ensures we can meet market demand without missing out on potential sales due to supply constraints. The upgrades enhances the product competitiveness and can justify premium pricing, attracting tech-savvy consumers. And advertising, crucial for capturing market share in a competitive landscape. All right. This balanced approach supports both production capabilities and market presence, aligning with the growing 3D printing market trends. Right. So this was a great example of how we can use reasoning to really think through the problem and also use the current data that you have, as well as do web research. And so this is why, this is so exciting, because of its capabilities and all the things that it can do. So let's go ahead and see where we are on time here. And we'll just do a few more just to sort of show you the range of things that it can do. Right. So this particular one, I wanted it to create a strategic guide to learn how to develop and launch a SaaS product for product managers. Right. And so it gave me a pretty, the results it gave me were pretty good, actually. Very, very thorough. And then the second one, the other one was, let's see here. This one, I was asking about the trends for e-commerce and how we can increase our ROI. Our marketing teams can increase our ROI on physical shipped products, assuming we sell camera accessories. That was actually pretty good. I really like the answer for that one. It gave me a lot of things that were pretty common for retail companies to do. Things like bundling offers and cross-selling, things like that. So it was a solid answer, actually. Let's see here. This one, that was the answer. Okay, that was the audio. Let's see. This one, I was asking. This one was pretty good because I wanted to actually test its ability to understand recent events and then use those events to give us recommendations or reason what would happen, what would have to happen if a certain event is actually taking place. So in this particular example, we have a small motorcycle manufacturing company, and we want to optimize our supply chain and maximize sales in 2025. What are some recommendations for dealing with potential 50 to 60% tariffs on imported parts from outside the USA? And as you all know, this is a big topic right now in the news with tariffs. And so what I wanted to do was I wanted to find out if it could become aware of the tariffs that are being considered at this time. And it did exactly that. It did the news search, and it says, according to the provided information, President Trump has threatened to impose tariffs on products from Canada, Mexico, and China starting February 1st, all right? It says these three countries are among the largest trading partners of the United States, and the imposition of tariffs could significantly impact both diplomatic relationships and global supply chains, all right? And so it's actually giving me information on the tariffs. And then the writer basically takes that information and applies it to our company, right? And so the first thing it says is diversify your supplier base, which is very, very smart. Invest in local manufacturing, leverage free trade agreements, okay. Implement just-in-time inventory management, negotiate long-term contracts, which is pretty good. Explore tariff mitigation programs, and then target niche markets. So it's really giving us some really, really solid advice for being able to navigate, this environment. And so the final thing it says is by diversifying your supply chain, investing in local manufacturing, leveraging free trade agreements, and optimizing inventory management, you can mitigate the impact of tariffs. So it's not just one thing; it gives us multiple things. Which is just shows you just how strong this model is. I did not expect this type of response, but it just shows you just the power of of a reasoning model that can go back and reiterate on the same prompts and create really outstanding results. All right, and so I believe that was the last one. That was the answer it gave me. And so you can see the power of this model and why it is really shaking up the industry and really disrupting a lot of things. It's an extremely powerful model, and when you use it with your agents, you can really, really go to the next level by creating some incredible applications. So with that, I will see you in the next video.